Alright, this is part 2 of if a series converges absolutely, then any rearrangement converges to the same limit. We had to show two things. I had to tell you what the capital N is there, and I had to tell you that this part is less than epsilon over 2. And actually there's a third thing that I neglected to tell you. What this really says is I need to show you that for all m bigger than or equal to some capital M, since I've already used an n, this must be true. So I actually have another thing I need to show you too, but they'll come up pretty naturally here. I need to tell you what that capital M is. Well, here's what's happening. I'm going to go over here to the side a little bit, do some kind of scratch work. Here's what's happening. Let's say I have a sub 1 plus a sub 2 plus a sub 3, a sub 5, a sub 6 plus a sub 7 plus a sub 8 plus a sub 9. Right, so let's just say that this represents our entire infinite series. It, of course, doesn't, since it has 9 things, and that's not even close to infinite. But I'm going to give you a rearrangement here. I'm going to rearrange it in a particular way. And this is only to give you the idea of what's going on here. Maybe it's a6 plus a3 plus a1 plus a4. Right, that one to get rearranged. Plus a9 plus a2 plus a5 plus a8 plus a7. What does that mean? Let's tie some notation to this. This is equal to b1, that's equal to b2, that's equal to b3, and so on and so forth. And in terms of the f, right, what this means is that f of 6, the sixth term in the original sequence, end up in the first place. So f sub 6 equals 1. F sub 3 is equal to 2. F sub 1 is equal to 3. F sub 4 is equal to 4. That's what the notation means. And let's suppose that somehow for some epsilon, we knew that maybe my n, which I told you right here, maybe my n is equal to 4 here. Well, what we're going to do is essentially, the way to think about this is, okay then, these three things are too big. Everything 4, 5, 6, 7, 8, 9 is small enough. So I want to make sure that I can take care of 1, 2, and 3 and not have to deal with them. Okay, brief interruption, sorry about that. So what we're going to do is we're going to go out far enough so that we don't have to deal with A1, A2, and A3. So let's see. Here's A1. Here are bad terms. Here's A1. Here's A3. Oh, and here's A2. So what I'm going to do is I'm going to make sure, maybe I'll pick my M to be here then, which is the 1, 2, 3, 4, 5, 6, 7. That way I know I'm going to avoid my A1, A2, and A3. So how do we write this up? We might write this up just by saying, you know, we can let M equal the max of all the f sub k, where the 1 is less than k is less than or equal to capital N, which I defined up here. So basically we just want to avoid those small ones. Well then, what we have here, now we can study for m bigger than or equal to m, we can look at Tm minus Sn, which is what we want. And to give you an idea of what this looks like over here, again on my scratch work, my Tm, let's say it's T7 minus S4, right? Because my capital N equals 4, my capital M equals 7, it could be 8 or 9. What's this equal to?